just take us through one of those three bottom
calculations
and tell us what's going on there?
Okay, so we've taken the Coburg weather station, in this case, the Peterborough and Minden here. We looked at our annual precipitation over, I think we've taken the climate norm from 1971 to 2000. That's your average annual precip, say it's 71. Then you look at your average annual temperature. Actually, you do this on a monthly basis and sum it up, to tell you the truth. You run that Thornthwaite and Mather calculation, and you have to make some, so I mean we have a report on this if you really want to chase it, but this is your actual evapotranspiration, so not your potential. So based on your soil moisture, how much moisture the soils are holding, if you put that into this consideration calculation, so you wind up with an actual evapotranspiration of 518, so that's what's leaving. That leaves you with 871 minus 518 is 353. So that's your surplus. So this water is available to either infiltrate into the ground or run off into the stream. Okay, so that's what you're working with. Everything else is used by the plants or gone. And then you take 55% of that number, and you wind up with the 194 for this area. So that's for the south. And in this calculation, we've looked at the whole south. That I showed you those three areas: the north, the central, and the south. So we partitioned the area based on the soil moisture capacity. So the aerial distribution of soils is considered in this calculation. So at the end of the day, you have 353 and your 55% number, which is where you call your significant groundwater recharge areas, is anywhere that you have a recharge rate above 194 millimeters per year. And so then you look at your estimated recharge rates, which of these exceed 194, and the ones in yellow exceed 194. So those are, and when you you can tie those right back to your superficial geology on the ground. And the same thing with the other two areas. So we have slightly different thresholds. The precip is much lower in Peterborough than in Coburg along the lake. So you've got a lower threshold here and then a higher threshold in the north.
Steve, what happens when you hit impervious surfaces like concrete? When you're doing modeling like that, if you try to do it within the greater, like in Toronto, what would happen to that?
The problem right now is that we don't have enough data to chase that. I mean, we're drilling wells in Toronto. Actually, we're kind of drilling at Southern Office at Downsea, but there's very little data, and it's a real bummer because we've been saying this for 20 years. And I think the only place that I recall is the Grand River Conservation Authority, when they were doing development in Laurel Creek and some of their watersheds. I know that way back in the mid-90s, they were putting in monitors to see if there was going to be because I mean, people will argue both sides of the fence. They'll say urbanization increases recharge because the pipes leak. So there's a whole school of thought that urbanization is great for the groundwater system. And there's another school of thought where it's terrible. So, and we don't have the data to really know that, to tell you the honest truth.
So this is not really applicable within an urban context.
Well, I mean, there's a lot of monkeying around with the knobs and buttons, pretending that we kind of know a lot more than we really do know. And so that's it's a caution there, because you'll get people who will be arguing to the death that the model results are, it's the model, and you have to doubt it. Right, and so it's really, really important that you question if things don't make sense in your head. I mean, that's what Rick always says, I mean, never be afraid to question the modelers, because they're, quite often they don't have time to think about what they're giving you. And I've even found that out, that, I should have chased them a little on this, right? Because, just things go so fast and so quickly, and you kind of think, everything, I don't want to. But if you see something that doesn't make sense, I mean, chase them on it for sure, and ask questions.
And it's only quality, it's only quantity, not quality that this is.
Yeah. Quality's a whole other can of worms.
Steve, we've got about 5 more minutes, and then we'll.
Okay. Why don't I go last? I don't think I'm much left. Why don't we go through it quick? So one of the things we did, so this is the end result of significant recharge areas. When we looked in the south, we thought, holy stink, there's a lot of significant recharge areas here. And from a practical point of view, we started thinking, how could we screen these out a bit? One of the things we thought of is, anywhere the water table is really close to the surface is probably a groundwater discharge area and very little recharge. So we ended up going through a process, next slide, of taking a look at anywhere where the water table was within 2 meters of ground surface, taking those areas and knocking them out of the significant recharge areas. So the black areas all came out. So it just enabled us to shrink those areas a bit. And we have a call in with M&R tomorrow to see if they want to chase us a little bit more or not. So we haven't really, it's just another methodology that we could use. And that's the end result of that, is just shrinking those areas a bit for more practical land use reasons. Wetlands. You said I'm talking about wetlands. I have 2 slides, I think. I don't have a lot about wetlands. And again, the fellow I mentioned earlier, Garth Vanderkamp, there's a lot of work on the prairies, some really cool work on wetlands out in the prairies. And again, closed depressions are an issue, and these Vanderkamp and Hayashi are trying to tease out a lot of processes tied to these prairie wetlands and how much do they recharge the groundwater flow system and so on. So I just threw 2 or 3 slides here just to show you what they're working on. So this is the kind of change in landscape that they've found. If you look at 1948 versus 1995. You would think that hydrologically you would see some sort of change there. I mean, of course we don't have the groundwater data to chase this, but just intuitively you would say, yeah, of course something must be different here. Next slide. And then our analogy in Southern Ontario, is this kind of thing that we see fairly often. Community in harmony with nature, or in tune with nature. I had to stop the car, but I saw this. Live in harmony with nature. Yeah. So anyway, we're probably affecting the hydrology in those systems. But wetlands. One thing about wetlands and then even lakes is that it really depends on the setting how they interplay with the groundwater system. So if you have a wetland that's up high in the topography, it might turn out that wetland is really a recharge wetland. It's recharging, it fills up with snowmelt and rainfall and recharges the groundwater flow system. In that intermediate setting, you could get a case where on the upstream side, the wetland is actually receiving groundwater. I mean, I'm looking, there's 2 things shown here. One is a more regional groundwater system, and the other is a more local system. So locally, the arrows are coming out of all of these 3 wetlands. But if you look at the deeper arrows, you can see here that you've got an inflow into this wetland area and an outflow on the down gradient side. So depending if you're up high or down low, and in this case, everything is discharging to the wetland. So really, and this is probably, it's important here too. I mean, we're in a much more humid environment in Ontario than they are in the prairies. But in the prairies, you can go to these wetlands in particular in the early spring. They're full, 5-10 feet of water in them. You can't even walk across them. And you go to the same area back in August, and it's bone dry, and you can walk right across it. So, recharge area. Whereas you go to these ones, and they're wet the whole year round. Anyway, they've done some papers and some work on this, and they don't. It doesn't look like the water table changes all that much. Moving from there's a bunch of papers here. I mean, natural grasslands versus agricultural fields, the wetlands. There's some very local differences in terms of the size of the wetland and how much vegetation's on the shores and so on. But I'm not going into details. I'm running out of time too. Okay, bonus. I just put a few points here. I don't know if they really sum up anything very much. It's complex. Recharge is complex. You can't really just go and measure it. Direct measurement, similar to that inner tube. If you go out and do a ton of measurements, it still doesn't mean you're going to understand your groundwater flow system. So be careful that people don't chase you to just measure with respect to recharge. The significant recharge area still needs a bit of work to really tease out what we're doing. I think I have one more slide. like my consultant buddies. You're not part of the solution. It's the money. Anyway, thanks for your time.
Good money.